Hello everybody. So I welcome you to the part 2 of the Matlab tutorial for beginners. Okay, so in this we'll start working a little bit with data analysis. Sorry for that. Okay, and also we will work on how to do some visualization and plotting. So first, as I said, that we would be working in command window, and there are variables. So we define a scalar variable a like 12. Okay, so I put a semicolon, so there was no display because it suppresses. Okay, so we have if you go to workspace, you can see that we have a variable called a, and it has a value of 12. Min and max are also 12 because it's not meaningful because it's just a scalar. Okay, the class is double. By default, all the numeric variables created in Matlab are double. Okay, so for example, if we create another variable, like we say 13.4, okay, so we see that both have been created. Okay, and now if I want to add these two variables, what I do is I can just type a plus b, so it's very simple. But we see that the answer is storing the value of the result of a plus b, the sum of a plus b, that's 25.4. so it has been assigned to the variable called answer, ans. Okay, just first three letters. So because we did not assign, so if we want, we can actually assign this to, for example, a variable c. You can use any name, but remember that the c variable c, small and capital, would be different. So what I want to highlight or point out is that Matlab has case sensitive. So Matlab, the variables in Matlab and naming is case sensitive. So small c, for example, we can use capital C here for, just to illustrate, for the product. So small c is a plus b, but capital C is a multiplied by b. Okay, so we have 160.8, so that's capital C. Okay, and so similarly, but the most important thing is when we try to use vectors. Okay, so there are many different types of vectors, and you can define in many different ways. So first, if we want to define a 3 by 3 matrix, there are many ways. For example, if we have some random values, so what we can do is we can write like for example, we are using a, and so you have to use these brackets. Okay, and then in brackets you will first enter first row, then you would use semicolon, and then you would enter the second row, and then you would use semicolon, then you would enter the third row, because we are trying to make 3 by 3, so each row would have 3 elements, so means 3 columns. So for example, we say 1.5.1 minus 2. So you can separate within the rows. You can either use commas or just the space, it's sufficient. But to get the new row, you have to use the semicolon. Okay, wait. Okay, so to separate for the rows, you have to use semicolon. So we have 3 and 1.1. Okay, and so then 15, 0, and minus 4. Okay, so if I will press enter, I'm not putting the suppressing command, that's a semicolon, so that we can see how it displays. So you can see that it displays a 3 by 3 matrix. Okay, so, and if you go to the workspace, you can also see, so the value is actually trying to write the whole, but because it doesn't have so much space, so it doesn't show the complete. But here the value of min and max and min become meaningful, because you can see that in this matrix we have the smallest value is -4 and the biggest is 15, so that has been shown. But all the elements, each element, because of that, the whole matrix is double again. Okay, So now there is another method also. So we can also multiply, we can also create, if we want to create some random matrix of 3 by 3, there is one command, use magic. So we can use this magic 3 by 3 and we will create a capital B matrix. Okay, so you enter, it's magic. So the magic is basically that if you do the sum of the rows or the columns, it will be same. Sorry, it's sometimes it's, yeah, so you see that the sum of all the rows is 15. So 3 by 3. So we have now two matrices A and B of the same order. Okay, now what we can do is we can try to get the division. So that's matrix division, you see. So that's the matrix division and some sort of plotting. Okay, so we want to plot a sine plot. Okay, and we say that we have some angle and we want to plot at least for 2. So we say we have angle theta. So one thing you have to remember, also one command is called CLC. So if you see that there is a lot of mess in the window and you don't want to see it, you can use the CLC. So it cleans the console basically. So the command window is now clean and we can, so we want to plot some variables. Okay, and how to do that? So for that we actually need some vectors. Okay, so vectors are particular form of matrices with, okay, just so one of the dimension is 1 and the other has n. So either it could be row vector or a column vector. Okay, so we say that we have an angle theta, but first you should know that if you want to use pi is already defined. Okay, so if we have a function and we are going to from, for example, minus 2 pi. Okay, so we want vector from minus 2 pi to pi and with very good division in between. So we say that this theta is assigned the value of minus 2 pi. Okay, minus 2 multiplied by pi. Okay, then we put colon. Okay, and then we say pi by 100. That's our incremental step. Okay, and then we put again and we would put the end value, final value we want to end. Now this would be a very large vector, so I would suppress it because it would not be useful to see all the values. So I just suppress it. So basically what it says, and we will check it into workspace. So we say, it says th variable has been created, and what it says in value, because it's a lot of values, so now it is not showing the values, but actually it's just saying that it has 1 into 401 double value. So the class or the data type is double, which is default, we know already that, but it says that it's 400, it has 401 values and only in one row. So basically it's a row vector. Okay, and you can see the minus and plus, so the maximum and the minimum value is basically minus 2 pi, that's 3 So we have the sign and we have this. So we say our function value along the vertical axis, it should be f. Okay, so we say, and it's a sine function, sine wave. So we say sine of the angle theta. Okay, we suppress. So we have, and both have the same. So for plotting, it's essential to basically use the same number of elements. Okay, so we say, okay, we select like that, and then we go onto the tab plot and we click this, and we see that 2 sine waves have been plotted because we just plotted from minus 2 pi to 2 pi. Dock it. Okay, so it's better. Now if you come to the command window, you see that we have a plot. We have a command called plot, and then we have the theta as the x variable, the first variable, and f as the y variable. So plot x comma y in the parentheses. So that's how you use. Basically you could use directly from the command window, but I actually asked you to use the plot. One more thing is to observe that when we go to this tool strip now, we see that now there are 2 more. We didn't have these 2 before. Okay, the figure and view. So before we just had first three, home, plots and apps, but this basically indicates that these are context based, so context driven tabs. So there are three fundamental, they are always there, but then there are also, when we are in a certain environment, the related tabs will appear automatically on the tool strip. So that command is called xlabel, and then we have to, because we are writing a string, so string has to be within the single quotes. So just write theta. Okay, press enter. So you can see here theta. So let's see. So you can see that sine theta on y-axis appears. So the same way you can change the length and everything. There is another way is you can actually view and edit the figures the way you want also. So if you undock it, you get these figure controls. Okay, so if you select here, you can actually select this. If you select the curve, then you can change the thickness of the line. You can even change the color if you want, and you can do many things. You can even change the style of the line, plotting. Okay, and you can actually plot markers, but markers, it would not be so useful because we have a very high frequency data. I mean, we have a very lot of data. So markers are when we have some sparsing data. Okay, and when you are done, just press this small box. Okay, so we have plotted, and similarly you can do many different types of plots. So you have to have data, and then if you go to the plots, you can see that we can plot bar plots, we can have area plots, we can have pie, we can have histograms, we can have the semi-log, full log, and the ones, there are some highlighted and some are not highlighted, because most of them are highlighted right now because they're all being they are all 2D plots, so they can all use this data and produce some results. Okay, so for example, if we want, so this would be, so that's something about plotting. We will see more into plotting, but I want you to practice now with this, and we can stop here. So thank you. If you like, please subscribe to my channel and also like the video, so that I can keep making more videos. And I'm going slow, but with the passage of time I'll pick up the speed, but I want you to absorb it and quickly follow me. And also I want you to experiment with the things, so try all the other graphs. We will see some more plotting in the next videos.